All right, so let's first evaluate the piecewise function. Which piece did you plug the 0 into? 0 is part of this interval here, so we'll go into the first one. Negative 0 plus 1 is just 1. What did we plug the 1 into? The second piece. What's another word for this type of function? Yeah, it's a constant. You just only get the 2 no matter what. And then finally, where'd you plug the 2 into? 2 squared is? Sounds good. And now we graph. Of these, which one would you say would be the easiest one to graph? Yeah, the one in the middle. It's just a constant, which is normally a horizontal line, but this one, the interval is infinitely small. It's just a point. It doesn't stretch out anywhere. So I would just put a point at 1, 2. So 1, 2, put a point there. Now let's do the other pieces. What word could you use to describe that piece there? Linear. So how many points should I need in order to draw a line? 2. And since there are 2 endpoints here, those would be the ones that make the most sense. So x and negative x plus 1, I'll plug in a negative 1, I'll plug in a 1. When I plug in a negative 1, I get 2. When I plug in 1, I get 0. Just plug those into negative x plus 1. The negative changes the sign, and then you add 1 with your fingers. So when I go negative 1, 2, and because that one has the or equal to sign underneath, I'm going to close that. Because the 1 does not have the or equal to sign at 1, 0, I'm going to open that. The last piece, what word could I use to describe the last piece? Quadratic. With quadratic, let's just get as many points as possible that fit in the graph within the interval. I should put the endpoint, which is at 1. But then the other points in the interval, those are numbers greater than 1, would be 2, 3, 4, however many you could fit. I won't be able to fit 4, because 4 squared is 16, but 1, 4, 9. What type of point am I going to put at 1, 1? Another open point. And that would make sense, because if I were to try to close that, it wouldn't be a function anymore. It would fail a vertical line test. 2, 4, 3, 9, and then we connect those stuff like that. So that's a weird looking piecewise, but it is a piecewise. So now let's answer some questions about this. What's the domain? Go ahead, Caroline. Negative 1 with a bracket or a parentheses? Bracket. This graph goes as far left as negative 1, and it actually does touch it. So we'll take a bracket. As you go right, are there any gaps or are there any discontinuities? There are no points where this would not be defined. If I were to drag a vertical line across, there would never be a point to the right of that where I'm not touching the vertical line. So then the question is, well, then how far right do we go? Yeah, positive infinity. And you could be like, yeah, but look, Mr. Romero, look at all this nonsense over here. Yeah, well, it doesn't matter. There's an output there. If you were to give me 1 as an input, I'd be able to give you an output. That output would be 2. Now, the harder one of the 2 is the range. That's the one you really got to think. Because there's no rule that, that you have to pass a horizontal line test. So I'll let Sid handle that one. What's the range here? Okay, 0 is good. What type of a symbol are we going to wrap the 0 around? Parentheses is good because we don't actually reach the 0. But the 0 is however low we go. And then on the way up, Are there any discontinuities? Are there any gaps? No, because if I were to go look at each little, think of it like a little lane. If I look at each little lane, there's always a piece of the graph everywhere I look. There's nowhere where it's empty. There's always some piece of the graph going all the way up to infinity. Infinities always take parentheses. Then towards the end of yesterday's lesson, we got into rate of change. What's another word for rate of change? Slope. In order to find slope, I need 2 points, and the 2 points are always going to be the endpoints. Now, the way we get the endpoints is that they give you the x's. So this is going to be -1 comma something and 0 comma something. This one here is going to be 2 comma something, 4 comma something. The numbers that they're giving you are the x's. You got to find the y's that go with it. We already found we found -1. That was one of our endpoints. What was the output at -1? How about at 0? It was 1. How about at 2? It was 4. And how about at 4? 16. You have to square it. That was a quadratic piece. Now we'll use slope formula like they do in the hood. M is equal to, subtract the y's, 2 minus 1 over subtract the x's, -1 minus 0. 2 minus 1 is 1 over -1, so slope is -1. Over this first interval, the slope is -1. Caleb, am I going too fast? For the second interval, subtract the y's on top. Caleb, what's the first y you see? 4. For the second y, just change the sign, so -16. That's like a shortcut. What's the first x you see? 2. Then subtract the second x, which is 4. That gives me -12 over -2. So the rate of change over that interval is 6. If you ever make it to calculus, that's what like half of calculus is finding rate of change over different intervals and then eventually finding rate of change at an instant. Anybody here take physics already? Do you guys do like instantaneous velocity versus average velocity last semester? Well, yeah, if that should give you like a head start if you have aspirations to reach calculus. That's a big part of Calc AB. Gotta go to the bathroom a lot. I tried doing that when I was younger. I just always having to go to the bathroom. It does get annoying, yeah, man. It's like, oof. I think it's a little too much. I think a gallon's too much. I think half a gallon's more appropriate. You gotta stay hydrated. That's true. Okay. Any questions so far? All right. So then let's do this part. Damn it, I didn't erase the. Well, don't look at the board. Because I erased part. I guess I didn't erase this part from last time. But try to see if you can graph these on your own. I'll give you a few minutes. And I'll do the work that goes with it too. I'll show you what the work looks like. No. Do it on your paper. Don't copy off of me, girl. What's wrong with you? Okay, for the first one, there's obviously three pieces. Of the three pieces, which would you say is the easiest one to graph? First one. Why? What type of a function is that? What type of a function is that? Constant, which a constant function is just, what does it look like? What type of line? It's a horizontal line. So I went and found 2, and I drew a horizontal line. I just had to pay attention to the domain, which only wanted it to be less than -2. So I went and drew a point at -2, 2, an open point, and then I went ahead and just drew a horizontal line to the left of that. The middle piece, what type of a function is that? What did I do? It is linear. How many points do I need for linear? 2. So I went ahead and did that over here. I just plugged in the endpoints. I plugged in -2, and I plugged in 2 and see what I got. If you look at the domain, both of these take closed points. So I went ahead and drew those closed points at what I got and connected the dots at -2, 1 and at 2, 3. The last piece, what word could you use to describe the last piece? Yeah, also linear. Okay, I went ahead and put in the endpoint, and then I just need 2 points. So I just picked any other point that falls in this interval, which is greater than 2. I picked 5 because I know Landon loves the number 5. But it doesn't really matter. You could have picked any point that you wanted. I got those 2 points, and I connected the dots. Also paying attention to the fact that at that 2, you have to have an open point. Once I connected the dots, that's what it looked like. Right, Miles? 4 out of 5 Miles agree. It's that last Miles. Yeah. I just picked 5 because 5 is greater than 2. I could pick any. If I didn't pick 5, what are some other numbers I could have picked? 4, 3. Yeah, 7 wouldn't have fit though, because I would have gotten 14. It wouldn't fit in my window. But yes, anything that's greater than 2. What number would you have picked, Caleb? Caleb tripping. What number are you gonna wear next year? You don't like single-digit numbers in high school? I like those. I haven't got that far yet. You talking about the second graph? Hannah, why are you always causing trouble, Hannah? All the best players take the single-digit numbers? Not necessarily. That's cool. All right, so now we move on to the next one. How many pieces do we have there? 3. The first piece is quadratic. Yeah, that's the one that's going to require the most amount of points. Those points can be anywhere from 0 and less. So that's what I did over here. When I plugged in 0, I got 1. And you might be confused because you're like, oh, wait, but that's a less than. And you filled it in. You know, why would you fill this in? Well, actually, I didn't. It was open, but you'll see why it gets filled in. And that's because now when you come to the next piece, which is linear, over here, all I need is 2 points. That's what I found here. They share a common point. So what happened was that linear came in, and that's what filled in that 0, 1. And then I just connected it to 3, 4, which is the other end of that interval. That one took a closed point. And then strangely enough, on this last piece, I went ahead and plugged in the 3 because that was the end point. I could pick any number greater than 3. So now if Caleb would have picked 6, that would have actually worked out well because I'm not just randomly picking numbers greater than 3. What would be the smartest numbers to pick? Divisible by 3. Fantastic, good. And it just happens to be that they also share a point. This 3, 4 is shared. That's why you don't see a gap anywhere. And if I connect that 3, 4 to 9, 6, then that's what that would look like. Any questions there? Man, are you alright, man? You thinking about unicorns? Sometimes that's what I do. Because it's like a horse, but it has wings. And the horn is just like the cherry on the top. What? You're a Pegasus. You serious? The unicorn doesn't have wings? Just the horn and that's it? Oh, that's boring then. You know what? My whole life then I've been living under the wrong. I loved unicorns because of, you just ruined it for everybody, Allie. I guess. Man, I could have sworn the unicorns had wings. Man. Alright. So this we haven't done yet. Now we're going backwards. Before we've been given functions and we've had to graph it. Now they're going to give us graphs and we have to write them. Which becomes a bit of a challenge because, not because you've never done it before, but it's been a while. And when you did it, there's a good chance that most of you were not very good at it. These are called regressions, and we're not that good at regressions, but we'll do the best we can to remember. First thing I would say you should look at is the number of pieces. So how many pieces do we have on this first one? 2. Let's just call, so that we can call them all something different, let's call this first one f of x equals I don't know what you're going to find easier, but I think maybe to avoid mistakes, it's probably better to do the intervals first before you start worrying about the actual equations. So clearly, like this right here is the separating point of the two intervals. So the first piece, under what interval is that going to take place on? And by the way, let's assume that we have arrows here. Since we don't have any points, let's assume there's arrows there. And here's another confusing thing. We're used to writing intervals in interval notation, but for these they write them in set notation. Just use the inequality sign. What inequality can you use to describe all the x's that are over here? Less than 1. So whatever I get for the first one is going to be when x is less than 1. Why not less than or equal to? Because it's open. And then the piece that's this way, how can I describe that interval? Yeah, greater than or equal to 1. All right. Now let's use words to describe the pieces. What words can you use to describe both pieces? Yeah, these are both going to be linear functions. In order to help prepare you for linear functions, let me remind you of what the two most common forms of linear functions were. The first one is probably the most familiar. What do we call that? Slope-intercept. The second one, I use it maybe more than most other people do, but what's that called? Who remembers that? Nobody remembers that? Point slope? You did it in geometry? It's possible. Might have used it for like parallel and perpendicular lines. All right, so let's see what we can do. This first piece, here we can tell by looking at it, it looks like it's crossing the y-axis at 2. So I know I should have a +2 here, but what am I missing? The slope. How do we find slope? We need 2 points. Euro rise overrun. Hi. You're coming into this class? Welcome, man. All right, well, I'm going to have to get you oriented a little bit later. Do you walk into all your classes listening to your music and stuff? Or just this one? Oh. At your last school, you could just walk into classes listening to? It's okay. Apology accepted. We have this little thing over there. I'll give you a number, and you can put your phone in there. We're halfway through class, so just have a seat. Yeah, I'll probably end up putting you here. You can just take this seat, and then let's do this. Today's your first day in school? All right, so we'll do it tomorrow. I'll let you go through your whole schedule, but tomorrow I'll give you a pass, and you can come during advisement, so I can help you get started with everything. All right, and what's your name? Abdul? All right, cool. What? Abdul or Abdur? Abdul, okay, cool. In order to be able to find the slope, I need the 2 points. So I got 0, 2. This gets a little hard sometimes. You got to be careful. You can pick whatever point you want. Just make sure that the line is clearly passing through it, or as clearly as possible. Is there a point where you're pretty confident that the line is passing through? We're looking at this left piece here. 2, 0? No, we're looking at the left piece, Kendall. I mean, I would say like -3, 1 maybe. -6, 0. And yeah, anytime I have a chance to pick something on an axis, I like those because I love substituting 0. So I'm gonna pick that one. Let's pick -6, 0. So slope 2 minus 0, 0 plus 6. Whatever comes second, you change the sign. Another nice thing about being able to see the graph, even before I found the slope, what did I 100% know about that slope even before I used slope formula? Based on the direction it was headed. Had to be positive. Positive slopes go up and to the right and down and to the left. So I know I had to get a positive, and luckily I do. I end up getting 1/3. So this first piece is 1/3 x plus 2. What school are you coming from, Abdul? Now you're back. Back again. Abdul's back. Tell a friend. Now let's go find the second piece. Now the second piece doesn't touch the y-axis. You could try to guesstimate where it would touch, or what I like to do better, which is to find it algebraically. I need 2 points again. Let's use the 1, 1, which is already shaded in here. Let's use that 1, 1. And then Kendall said 2, 0. What Kendall wants, Kendall gets. Except reading time. Slope is 1 minus 0 over 1 minus 2, which is 1 over -1, and that makes sense because we already knew it was going to be negative. So I know this first part is going to be -x. I just don't know where it would touch the y-axis. You could try to say, well, look, if I were to keep on going, it would cross at 2, but I'd be careful with that. Let's do it algebraically. There's 2 ways to do this. I'm kind of on... I did it the way I'm used to first period, but I saw a lot of blank faces. But every day I see blank faces, I guess. And today I asked you guys about point slope, and most of you never heard about it. So I'll just do it this way both ways, and then I'll let you pick which one you want me to do going forward for finding y-intercepts. If you were to do it the way I'm used to, which is by using point slope, pick one of the 2 points. These 2 points that we just used for slope, pick one of them. It doesn't matter which one. All right, let's use 2, 0 because Emily also gets whatever she wants. And then we're going to plug that in there. We're going to say y minus, what's the y of that point Emily just picked? And normally you'd put it in there, but what's anything minus 0? Itself, so I don't need a minus. I'll just root y equals. the slope, which we just found at -1, parentheses, x minus the x of that point, which is 2. And then now all you got to do is solve. You get -x plus 2, which completes what we had here. That's one way of finding a y-intercept. The other way is to plug it into point slope. If that's the case, and what I'd be looking for is b. Okay, I'm looking for this b. I got to plug in a y, an m, and an x. It's the same thing. Pick a point. Let's say Emily still wanted 2. But now that 0, you would actually plug it in for the y. And then you would say m was still -1 times the x, which is of that point, which was 2, plus the b. So you would get 0, -2 plus b plus 2 plus 2. 2 equals b. And either way, you still end up with the same y-intercept. Which way do you like better, the first way or the second way? Second way? Oh. Well, he just got here too. Alright, I'll do it the second way then, I guess. Any questions on that one? Alright, let's move on to the next one. Then I'm going to erase this to make space. Here, Abdul. I print out all the... You have friends in here? You don't have any friends? Me neither. You want to make some friends? Zeke's pretty popular. Mostly with the ladies, but he's got guy friends too. How many pieces does this next function have? It does look like 3. Let's just call this function g. Yeah, let's put this off to the side here. Let's make it all fit. Maybe not. Can I get it to fit there? I'm gonna run out of space. Let's go here. You're probably better off doing the intervals first. So since I have 3 pieces, it looks like I'm gonna have 3 intervals. How could you describe? Oof, wow, that's bad. Wow, that's even worse. How would you describe that first interval all the way to the left? Does it look any better on your paper? No. How can you describe, like, what do you call all of the x's that are on this side to the left? Less than -2. So whatever the first interval is going to be when x is less, and it's not going to be less than, it's going to be less than or equal to -2. Why less than or equal to? The leftmost piece has a solid endpoint. And even though we don't see arrows, we'll assume that these should have arrows that just got cut off. How about the middle piece? Well, it goes as far left as -2 less than x less than or equal to 2. And then finally the last piece. X is greater than 2. What do you think would be the easiest piece to define? The middle one, sure, because that's just a constant. What's the output there? What's the output on that middle part going to always be? What's the output here going to always be? no matter what the input is. And what's the y there? What y are we? 4. Okay, so that piece is taken care of. The other two pieces appear to be linear. So I'm going to need a slope and a y-intercept. In both cases, we need 2 points. So let's see, 2 points that it looks like fall on this left. I'd say -2, -5. And then, I don't know, pick another point. Where are you at, Emily? Like it looks like -3, -8 is the only other one I can kind of see there. -3, -8. So let's find slope. First y is -5, then +8, -2 +3. So I'm getting a slope of 3 over 1, which is 3. And that makes sense because it should have been positive anyways. So I know this first part of the first piece is going to be 3x because I'm using slope intercept. But I have to see where it's going to cross the y. You guys voted overwhelmingly to choose to go back into slope intercept. So pick a point again. Go ahead, Zeke. I'll let you pick. Pick a point. Here you go, Zeke. I'll help you out. I'm world renowned for my arrows. Pick a point, man. It's okay. It requires listening. Okay, -3, -8. So I would put the y of that point, -8, is equal to the slope, which is 3, times -3 plus b. So -8 is equal to -9 plus b, and Abdul likes this way, he gets 1. So +1. If this piece were to continue, it should be crossing the y at 1. The last piece, same thing as a line. I need 2 points. It looks like 2, 0 is going to be one of them. Zeke, you want to try to redeem yourself? Okay, give me another point that's part of that last piece. -2. Okay, Zeke, never mind. Let's go to Yash. I haven't talked to Yash today. Yash, give me another piece, another point that's part of that last piece on the right. It's my fault. I'm just not a good enough teacher. That's what. Caleb, you want to help him out, man? I got that on the board already, Caleb. I got that on the board already. Like it requires listening. Huh? 2, 4. So you're saying up here, yeah, that's part of this last piece. Got it. Got it. Yes, that's. If yeah, one more. 8, -3. Okay, that could work. So there you go. And it only took like three tries. M is equal to 0 plus 3. 2 minus 8. So that's going to be 3 over -6, which is -1/2. My slope is -1/2. I could put in -1/2 x. I still need a y-intercept though. So Abdul, pick one of the 2 points. I mean, is it me? Like, am I just? I'm even leading you by saying pick one of the 2 points. I'm not just saying, see, because Zeke got thrown off. Zeke wasn't paying attention. And I told him pick a point, and he's like, what the heck is this guy talking about? Pick a point, and he just randomly picked his favorite numbers. But like I'm telling you, if you're following along, go ahead, Hannah. Yeah, fine. 2, 0 will work. It's not a trick question. So if I pick 2, 0, I put the 0 where the y goes. The m is -1/2. The x is 2 plus b. So 0 equals -1 plus b plus 1 plus 1. So that y-intercept here was plus 1. You're not going to have a ton of regressions on your test and quiz, but just you got to know how to do them. One more of these. Let's see if we could all focus all of our senses. No questions on the last one? Okay, how many pieces does it look like this one has? It does look like just 2 pieces, yeah, and it's a little bit harder to tell because there's no discontinuities. It's all continuous. We'll assume that there's arrows up there, but it does look like 2 pieces, and the pieces are separated there. Let's call this, just to separate it from the rest of them, let's call this function h. What interval would I say the first piece is on the left? How could I describe that interval? Okay, now you might get, well, wait, but I don't get, is it less than -1? Is it less than or equal to? I don't know. Well, because they're continuous, it really doesn't matter. Because you're going to get the same output regardless of what piece you put the equal sign on. So I'll just go with, let's go with x is less than -1 here. Keep this separated. Let's go with x is less than -1, which means that on the right side, we're going to have to call it x is greater than or equal to -1. What word can you use to describe the leftmost piece? Linear. So I need just like the same ones before. I need to pick 2 points. It looks like 1 point was kind of picked for me already, so I'll just go with it. That is at -1, 5. Now I need 1 more point on that line. Go, Emily, go, Emily, go, Emily, go. Good, you have good eyes. Or whoever whispered it to you has good eyes. Good. -2, 7. So 5 minus 7, -1 plus 2, -2 over 1. The slope is -2, and that makes sense because it's going up left and down right, so it should be negative. So I know the first part of this piece is going to be -2x. Sweet Caroline, oh, oh, oh. You should pay attention now. Wake up, wake up, wake up. What am I missing? Y-intercept. So pick a point. Go ahead, Abdul. Let's redeem yourself now, buddy. Pick a point. 4? Oh, dear. Go ahead, Lauren. Doesn't require a lot of thinking. -1, 5. Sounds good. That's one of the points we had already. -1, 5. So I'm going to put the 5 for the y. The m was -2. 5 plus b. So 5 is equal to -10. Oh, wait, that doesn't make sense. What did I do wrong? I put 5. Oh, no, because I put the 5 twice. This should be -1. The x was -1. It's all Abdul's fault. So 2. Poor Abdul doesn't know what he got into. The slope is 3. I'm sorry, the slope. Sorry, the y-intercept. If that were to continue going down, it should cross at 3. Yeah, that makes sense. So -2x plus 3. And then now what may or may not be the trickiest part, which is a quadratic regression. Not only did you do this in Algebra 1, like you did linear regressions, but we also did this at the beginning of the year also. At the top of this page, I put the 2 most common forms of linear functions. What are the 2 most common forms of quadratic functions? That's what it looks like. I'm talking about like how to arrange So I wrote the two most common forms up here at the top. What are the two most common forms for parabolas? Oh dear. Standard form, which was y equals ax squared plus bx plus c. That's the one you use probably most often. But for graphing, believe it or not, the easier one is what's called vertex form. Did it at the beginning of this year. Vertex form, where we can now just look for A, H, and K. And since that's beneficial for graphing, that's what I'm going to do. Whoa, but Mr. Romero, what happened to C? We've been working with C lately. Well, there's no need for a C because we know that like vertical stretches look like horizontal compresses. Vertical compresses look like horizontal stretches, and the only other thing that C could do is a y-axis flip. But if you get a parabola and flip it on the y-axis, it still looks like a parabola. So C doesn't really get introduced with parabolas. There's no need for a C. Where could you find H and K? Who remembers this from the beginning of the year? The vertex. The vertex here is at 1, 0. So my H is 1. My K is 0. The A is what requires a little bit of work. Some teachers kind of teach you to cheat a little bit when it comes to A, which would just be to go, if you look at where the vertex is, just go 1 over, see where that's at, and then just take the slope, which I guess works, but the thing is, it wouldn't always work, because if that 1 point over was somewhere floating here in the middle, you wouldn't know where it's at. I prefer to teach you the proper way of doing things. So go here. In order to be able to use that to find A, I have to be able to plug in something for everything else. I have an H and a K to plug in. I just found H and K at the vertex. What do I still need in order to be able to find A? What would I have to also be able to plug in? X and Y. Where do I find an X and Y? Pick any other point that's on that piece. Emily, you've done a heck of a job of that. Can you pick another point that's on that piece? No, but I already picked one. You can't pick the vertex again. Say it again. Okay, fine. I was looking to pick something a little further out, just so you see that it works. How about this? Is it okay if we pick 3, 4? Okay. So if I pick 3, 4, I'm going to put in a 4 for Y. Then the A is what I'm looking for. The X was 3. H was 1. Squared plus K, which is 0, so we don't need it. 3 minus 1 is 2. 2 squared is, so 4 equals 4A. Once you divide by 4, now I know that A is 1. And I was kind of on the fence with this with first period, but I'll just tell you guys, because now that I have everything I need, I can say that this is going to be like leave it in vertex form. So it would just be X minus, because since A is 1, you don't need the A, X minus 1 squared. So I wasn't sure whether to make them simplify that or not. That's fine. You can leave it in vertex form. Let's see who's paying attention. Where did I get that 1 from? H. Yeah, it's not the one I just found. It's from the H. This one that I just found comes in front of a parenthesis, so I just don't need it. Okay, the last one before we leave, word problem. Sprint offers a monthly cell phone plan for $35. It includes 300 anytime minutes. Yeah, back in ancient times, the cavemen, they used to be charged for their cell phones by the minute and not by the gigabyte or whatever. It wasn't data, it was minutes. So this is kind of an old problem. But let's write a piecewise function that can be used to compute the monthly cost for a subscriber, where X is the number of anytime minutes used. So cost depends on X, which is the number of minutes, equals. How many different ways can you be charged? Like how many intervals should we have here? 2. The first interval should be if you talk anywhere between 0 and 300 minutes. What should the second interval be? Anything that is above 300. X is greater than 300. The first piece should be the easy one because that's a constant function. Regardless of whether you talk between 0 and 300, how much are you going to be charged? 35 bucks. So that's constant. The second one is where it gets tricky. Anything over 300, and I'm going to do this off to the side here, you've already been billed the 35, but plus they're going to charge you 40 cents per minute, which is 0.4, but only for the minutes after 300. So you would take the total minutes and take away the 300 because for those 300 you were already charged 35 bucks. If you wanted to simplify that, you could distribute 35 plus 0.4x. 0.4 times negative 300 is minus 120. Combine like terms, that gives you 0.4x minus 85. Check my math. What's 35 minus 120? Should be negative 85, right? Alright. So this will be 0.4x minus 85. That's in simplest form. How much does it cost you if you were going to talk for 200 minutes? Where would this 200 fall in my domain? Where would it fall? It would fall on the first part, with the first piece, which is the constant. It would just be 35 bucks. How about for 301? Where does the 301 fall? On the second piece, so it would be 0.4 times 301 minus 85. Somebody with a calculator, tell me what that gives you. Well, actually, I should already know that. That should end up being $35.40. Duh. Because it's check. I mean, if you want to check with a calculator to make sure it works, but that's what you should get. Because it's the 35 bucks plus the 1 extra minute. And then the last one, 420 minutes. 0.4 times 420 minus 85. How much does that give you? 83 exactly? So $83 exactly. Tomorrow I'll give back the test. I'll also continue with this. I booked the lab for Friday. Today was not a very good day. If I were to predict, we probably will not end up in the lab on Friday. This is taking way too long, and it has to do with just people that are drowned out, like their brains are somewhere else. So if we can pick it up the next 2 days, maybe we make the lab on Friday. Up to you.